Today we are going to talk about modeling situations with equations, and it is part 2. In the past, we worked on setting up one-step equations, and now we are going to work on two-step equations. The steps are the same, and the goal is the same. So our goal is to be able to replace words, a story, with numbers or variables to set up an equation based on the situation. So when we model these equations, our first step is to write a verbal model. So we're going to use words to tell our story. So we are going to take a step back. We are going to ignore the numbers that we see in our word problems, and we are going to just think about what is happening. We are going to tell that story using words and operations. We will use operations. Words and operations. Once we have written out our verbal model, we will move to step 2, where we will translate these words, operations, this verbal model into a mathematical model. So we'll put back in our numbers and our variables. The other important thing here is that we will need to use a let statement. So we will be using variables and because we will have an unknown number. So we will write a let statement defining what that variable is. Step 3, we will solve the equation. And step 4, we will answer the question that is being asked using a full sentence. We will focus primarily on steps 1 and 2, but I will work through one entire problem with all 4 of these steps, just so we can get a feel for the whole entire thing. But we've already practiced solving equations, so I want us to focus on the verbal model, the math equation, and your let statements. One more thing that is important to note is when we create mathematical models, the variable cannot be isolated. So we can't have 2 times 3 plus 5 equals x. The variable cannot be alone on one side. It needs to be immersed somewhere with the other numbers. All right, so let's give it a try. We've got Joe. Joe ordered a pizza for $8, and every additional topping is 50 cents. If Joe paid $10.50 for his pizza, how many toppings did he have? So this is where I take a step backwards. I ignore the numbers. I don't want to look at the numbers. And I ask what the story is. Well, this guy named Joe, he went to a pizza place, and on the menu it said that he could buy a pizza, and that was like a flat rate. So however much you bought a pizza, let's say it's a large pizza, and that is a certain price. And then you can add toppings, and every topping that you add is an added price, getting you a total amount of money. So our step 1 is to write a verbal model. So we're going to use words and operations. Words and operations. Okay, so the pizza itself costs a price, and we add that to the money per topping that then gets multiplied to the number of toppings. So this might be where you ask yourself, you need to take a step back. Like if I have 10 toppings, I would multiply that per the amount of money. Okay, and then that equals the total price of my pizza. Total pizza price. So I've got the basic pizza, that's one price, and then I add that to these 2 that are combined. The amount per topping and my number of toppings will get multiplied for a total price of my toppings that gets added to my pizza for a total pizza price. Okay, So now we think about what numbers we do have. Well, I have $8 for my pizza. I know that each additional topping is 50 cents. So that's money per topping. And then I know that Joe paid this much, $10.50 for the pizza. What I don't know is how many toppings did he have. So I don't know this. So that is what I will write my let statement for. So I'm going to say let P be number of toppings. Okay, so from here, I go ahead and substitute in my actual mathematical equation for that verbal model. So pizza costs $8. I add that to money per topping, which is 50 cents. And that's going to be multiplied with my number of toppings. I don't know my number of toppings yet, so I'll write P. And all of that equals 10.50. So my equation then is 8 plus 50 times 50 cents, times P equals $10.50. Now, the reason we keep that P here is perhaps maybe Cindy goes to get pizza and she has a different bill. So this equation can be used for anybody that orders pizza there. This would change. So if Cindy wanted to determine how many toppings she had, this might change to say $15. And then we would go ahead and then figure out what P would be in that situation. All right, but for now, we're going to solve this equation that we have. We've got 8 plus 5/10 P equals 10 and 5/10. So I can get rid of those zeros for now, or you can keep them there. I've got to box my variable term. Positive 8 to get rid of that. I inverse to get me a negative 8. Now I'm left with this. Oopsies. Okay, now I divide by 5/10. Running out of room. P equals 5. Now when I plug that back in, 8 plus 0.5 times 5 equals 10.5. 0.5 times 5 is 2.5 plus 8 equals 10.50. So I am correct. So now I would answer that question. The question was, how many toppings did Joe have? Well, Joe had 5 additional toppings. And that's that. So you started with your verbal model, you took a step backwards, removed those numbers, looked at the story that was occurring. Then you took that verbal model, gave us a let statement, followed by a substitution of the information in our story problem to get us an equation. Then step 3 and 4, you solve and then answer the question. Remember, we will focus on steps 1 and 2. So let's try that now. Okay, so Julia was going to sell some of her stamp collection. After selling half of them, she bought 15 more. How many did she start with if she has now 43? So I am going to think for a second, and it says that Julia had stamps. So I'm thinking about the story, ignoring the numbers. She had stamps. She sold stamps. She bought more. And we want to know how many she started with. Okay, so she had stamps. She sold some. She bought more. She has a new amount. So we'll write that out in a verbal model. So she had stamps. Julia had stamps. And it says she sold half. So I'm going to divide that amount by half of the collection that she sold. This will get added to she bought more. So I know that buying more means she's going to increase. So that would be our addition. And that total then will equal amount she has now. Okay, so I go ahead and think about what information I have and what I don't. Julia had stamps. I don't know that. That's our question. How many did she start with? I don't know. Half of the collection. So if she lost half, that would be dividing by 2. Then she bought more. It tells us that she bought 15 more and that she has 43 now. So my let statement will be how many Julia started with. So I'll say let S be stamps Julia started with. Then I will go ahead and take this and turn it into my mathematical equation. So I say, okay, Julia had stamps. Well, I don't know what that is. So that's S divided by 2 plus 15 equals 43. A more appropriate way, the more common way that we would see this would be S over 2 plus 15 equals 43, although both options are okay. So what's going to happen now is you're going to go ahead and work through an assignment. You will focus on steps 1 and 2 for every problem. 1 and 2. Once you get to 1 and 2 for all the problems, you will go back and do 3 and 4, but focus to start on that step 1 and 2.